Hello everybody, today we're going to be talking about how to find the area of a regular polygon. So what you're going to need is a pen or a pencil, a calculator, and your foldable if you have it. And remember, if you don't have a foldable with you, you should be writing these notes directly into your notebook. But I do have a foldable if you are provided with one. With that, let's get started. So before we can find the area of a regular polygon, we should probably talk about what a regular polygon is. A regular polygon is a polygon that has equivalent sides or congruent sides. So side lengths that all, or sides that all have equal lengths. So that would be a side. If we're talking about a polygon inside of a circle, from the center to a vertex is the radius. If you had a polygon inscribed in a circle, so if you were to draw from the center of the polygon to a vertex or a given point on the polygon, that would be the radius of the circle that it's inscribed in. So we call that part of a polygon the radius. And the perpendicular distance from the center to the midpoint of the side is the apothem. It sounds like a possum, but it's not. It's called the apothem. A-P-O-T-H-E-M. So in the middle of your foldable, you should have a pentagon, a regular pentagon, and you should have this triangle there for you, and then just write this vocab as it is on the triangle. So write the sides, what they are, radius, and apothem. Hopefully you know what the side of a polygon is, but we have some new terminology as far as the apothem goes, and we can also have radii or radiuses in non-just circles because we think about those shapes being inscribed in a circle. So long story short, make sure you get this stuff written down in your notebook by drawing the picture and then labeling the parts, or if you have the foldable, just labeling the parts. Okay, so the goal for us today is to find the area of any given regular polygon. In this case, we're going to be looking at a pentagon, and then in example number 2, we're going to be looking at a hexagon. But first, let's start with a regular pentagon. So how do we find the area of a regular pentagon? If you ever come across a question, whether it's in my class, whether it's for a state test or the ACT, and you are asked to find the area of some shape that you may not remember the formula for, or you may not even know a formula for it to find the area, you always want to break down, like worst case scenario, if you do not know how to find the area of a complex shape, you want to break it down into shapes that you do know. So the basic shapes that you should remember always from like elementary school and middle school are triangles, squares, four-sided figures, three-sided figures. Those are pretty simple. Anything that gets more than 4 sides gets to be a complex shape. So if we were to draw all the radii in this pentagon, so from the center to the vertex, if we draw all 5 of those, 1, 2, 3, 4, and then this purple one's 5, we have 1, 2, 3, 4, 5. We cut this pentagon into 5 triangles, and we know that the area formula for a triangle is 1/2 times the base times the height. So this would be, the red line would be your base, and the apothem, or that blue line, would be your height. So you can find the area of a polygon by taking the area of one of these triangles, I'm trying to highlight it for you, one of these triangles, and then multiplying whatever we get for this area in this triangle here times 1, 2, 3, 4, 5. So to sum up, we can find the area by just finding the area of one of the triangles. If we break it up from the center to the vertex into 5 triangles, and then multiplying that area of the one triangle by 5, or we can change that formula and we can call it 1/2 times the apothem times the number of sides times the side length. So this is our formula, and it should be in your foldable, but the A stands for the apothem. The N stands for number of sides, and then the S stands for the side length. But that's where this formula comes from, is if you break a pentagon into 5 triangles and find the area of the one triangle and then multiply by the 5 to get the whole area of the polygon, that's how we get it. So using that formula of area equals 1/2 times the apothem times the number of sides times the side length, let's do two examples where we find the area of the regular polygons, the first one being a pentagon, and like I said, the second one being a hexagon. So for example number 1, we want to find the area of this regular pentagon with a side length of 4 inches. So if we pop out that square that we divided, we know that this whole entire side is 4, but if we cut that guy in half, we know that this side length is 2 and this side length is 2. And our goal is to find, because we know how many number of sides a pentagon has, it's 5, and we know that the side length is 4 up here. So really all we have to do is find that apothem distance or length. So we're going to label the apothem little a. And so we have to use, it looks like an equilateral triangle, but we don't know that for certain. So we have to use previous knowledge of, like, I don't know, say SOHCAHTOA or special right triangles to solve for that unknown side length. But before we can get to that step, we first have to figure out how many degrees are somewhere in this triangle. Like, we need angles. Somehow we got to get angles involved, right? So we know this one's 90 degrees because we dropped that perpendicular, but we're going to need some more information than that. So in a previous video, the most recent lesson that we just learned, we learned that in a polygon, how you figure out how many degrees are in a total pentagon or hexagon or whatever, we use the little formula of n minus 2 times 180. So if we have a pentagon, we should take 5 minus 2, which is 3, times 180. So we know that 540 degrees fills up every single one of these angles. So this angle, this angle, this angle, this angle, and this angle added together all add up to 540. So if we do that, so we have an interior sum of 540 divided by 5 interior angles. We know that one of these angles is 108 degrees, but this radius is cutting that angle, each angle, exactly in half. So if we take 108 divided by 2, then we know in our little blue pop-out triangle that this angle is 54 degrees because we took 108 and divided it by 2. So now that we know that, we know we can find the apothem distance by using SOHCAHTOA, because 54 degrees is not a 45-45-90 or a 30-60-90 triangle. So we're going to have to resort to the good old SOHCAHTOA. So from this reference angle of 54 degrees, we have an opposite side and an adjacent side. So that means we're going to be using the tangent function. So tangent of 54 degrees is equal to little a, the apothem, over the side length of 2. So in order to solve for the apothem, we have to take 2 times tangent of 54. And that decimal is, let me just punch that into my calculator, 2.7528. So that is the apothem distance. So remember, we want to find the area of the whole pentagon, regular pentagon. So area is 1/2 times the apothem times the number of sides times the side length, right? So we just found the apothem to be 2.7528. The number of sides in a pentagon is 5, and the side length for our pentagon is 4 inches. So if we multiply 1/2 times 2.7528 times 5 times 4, we get a grand total of 27.5276 inches squared. We're talking about area, and we know that the side length is inches, so then the area then would be inches squared. Okay, let's try another example. Number 2, find the area of a hexagon, a regular hexagon. I know it doesn't say that, but we'll assume that it's regular. A regular hexagon with a radius of 9 inches. Okay, so we got to label some stuff in the triangle. So the radius, remember, is from the center of the hexagon to one of the vertices. Sorry, that's supposed to be a little bit straighter, but that's okay. So one of the vertices. And so if we drop that apothem distance, we know that this is 9, and then we got to find some other information, because remember, we're trying to find 1/2 times the apothem, which we don't know, so we'll call that little a, times the number of sides, which we know is 6, and we even have to figure out the side length, this whole side length. So we're going to have to figure out this guy, which I'll call x, and then we'll have to double him for the entire side length. Okay, so we're going to have to recall that formula where we take to find the sum of the interior angles. So we're going to have to take 6 minus 2 times 180. So 180 times 4 then is 720. And if we divide that by 6, we know each angle in a hexagon, regular hexagon, is 120 degrees. So then for this radius right here, if he's cutting that angle exactly in half, then we have a 60, 30, 90 triangle, because 120 divided by 2 gives us 60 and 60. So if we have a 60, 30, 90 triangle, then we know our shortcuts, or we should remember our shortcuts. If you don't remember your shortcuts, you can also use trig if you totally forget shortcuts, because we're going to have a rounded answer at the very end anyways. But remember the hypotenuse, or the short leg times 2 gets us to the hypotenuse, so that would mean that the hypotenuse to the short leg we would have to divide by 2. So this little side length is 9 divided by 2. Okay, and then the apothem then would be 9 divided by 2 times the square root of 3. So the apothem would be the short leg times the square root of 3. So for my solution then, I have 1/2 times the apothem, which is 9 square roots of 3 divided by 2, times the number of sides in a hexagon is 6, times the side length. Well, we found this little distance of x to be 9 divided by 2. So if we double that to find the entire side length, if we times by 2 or double that, that gets me back to S being 9 inches. So we now can find the answer for the total area. 1/2 times 9 times the square root of 3 divided by 2 times 6 times 9. So the first thing I would punch into my calculator is this 9 times the square root of 3 divided by 2. So punch in your calculator 9 times the square root of 3 divided by 2 times 0.5 times 6 times 9. And then our total answer then would be 210.44442 if we round. And that would be inches squared again. So that's my total area for the whole entire shape, hexagon. Sorry, I totally blanked. Okay, so we got a 30, 60, 90 triangle in a hexagon, and that is going to happen in every single regular hexagon, but it only happens in hexagons because hexagons are special because of that characteristic of 720 getting divided by 6 getting to 120, half of that is 60. So you will notice when you're doing hexagons, regular hexagons, this triangle, if you break it up into the side and then draw the radii, this triangle is always going to be equilateral. And then if you cut that in half, that's how we get the 60, 30, 90 degrees. So only in regular hexagons do you have it break down to a 30, 60, 90 triangle. That is not true for every single regular polygon, but it is true for regular hexagons just because of how the degrees flush out with a hexagon and how it's symmetric and all the properties about hexagons. So anyway, today's lesson was all about finding the area of polygons, regular polygons, and how we do that is by taking 1/2 times the apothem times the number of sides times the side length, which breaks down to just dividing up every single one of your regular polygons into triangles, finding the area of that triangle, and then taking that area times however many triangles you break it up into or however many sides that shape has. With that, I'm going to leave you to it, and I want to thank you for taking good notes, and I shall see you soon.